This is Neil Schneider for MTBS-TV at CES 2017. To my immediate right is Oliver Gunnesekere, who is CEO of NGCodec. Welcome to the program, Oliver.
Thank you very much.
So tell us, what does NGCodec do?
We do next generation video compression, specifically focused on VR and AR.
Okay, so why is this, you'll forgive my choice of words, but why is this important?
It's important because there are challenges with today's VR that it's very expensive if you want a really good experience. And so by moving that rendering to the cloud, we can significantly reduce the cost because you can pay as you play versus having to buy a $2,000 gaming rig.
Okay, so let's rewind a little bit. So under normal circumstances, when people are using a virtual reality device like an HTC Vive or an Oculus Rift or even through mobile, all the processing is local. It's either on your head in an attached computer. So when we're talking about having VR through the cloud, what are we talking about?
We're talking about moving that processing from being on the PC to a cloud resource and then delivering it with a video encode, ultra low latency, direct to the HMD.
So what would be advantageous about having virtual reality available through a cloud platform?
There are basically three benefits. The first benefit is that you can have incredible compute capabilities, really high-end CPUs and GPUs, something that mobile you could never do because you're firmly limited. So the first benefit is that we allow state-of-the-art, even higher performance than you could get in the desktop. The second is cost. The problem with these high-end compute capabilities is that they're super expensive. This laptop we're using here is a $3,000 laptop, and it only gets used about 1% of the time. We're sleeping, we have to go to work. Whereas if we put that in a data center, we can share it with many, many users. The utilization can be 60, 70, 80%. So maybe you pay $10, $20 a month to use this service instead of having to spend a lot of money. That's the second benefit. The third benefit is battery life. We want to have a mobile HMD, but the problem is that if we render it locally, we get about 1 hour of battery life, and the performance is 100 times less what you can do with a desktop. So by turning the HMD into effectively a dumb HMD, where all it does is detect the motion and play back the frames, it significantly reduces the power requirements, giving you much longer battery life.
Okay, good stuff. Now, one of the challenges with cloud-based, especially cloud-based gaming, is latency. Okay, that delay from point A to B and back to A. So, how do you handle that? I mean, virtual reality is so dependent on having little to no latency. Is that a core concern with cloud?
Absolutely. It's the number one concern, and you have to optimize latency across the whole system. It starts with having great compression technology that not only can deliver extremely low latency, a few milliseconds, but is optimized to provide great compression, because obviously the bandwidths to homes are not huge. But then you also need a modern network. You're not going to be able to do this over a legacy cable network, for instance, legacy copper. What you need is someone that might have fiber to the home with modern carrier-grade Wi-Fi or a 5G cellular connection. These can provide a few milliseconds ping to a local data center. So for example, in my hotel here in Vegas, I now have a 3 millisecond ping from my laptop to the local server. That is perfectly doable of cloud VR. We typically have a 20 millisecond budget for everything.
Now, one of the challenges especially with cable internet, high-speed internet, is you have a download rate which is really high, yep, and then you have an upload rate which isn't so much. Yep. How would that impact a virtual reality platform?
Actually, it doesn't, because we are very much asymmetric. If you think about it, the graphics data that you're watching is coming down. So that's the big pipe. What's going up is your movement vector and potentially your eye tracking. So the amount of data that's going to the cloud is a fraction, maybe 100th or 1,000th of the amount of data that's coming down. So the asymmetrical infrastructure that we have for public internet actually works really well for cloud VR and AR in the future.
Good stuff. So I tried it out, but maybe you could explain for our viewers, what do you have on display here?
Yeah, so what we're showing is really an A/B test. So we are showing an HMD connected to a high-end PC that's playing a high-end VR game. And in one configuration, we're not doing anything. It's just going direct via HDMI, uncompressed at 3 gigabits a second to the HMD. In the second mode, and we just switch it, it goes through our encoder. So we're actually encoding the system at 250 to 1. We're using H.265, so we're reducing that 3 gigabit data rate down to 15 megabits. We're sending that over the Celino Wi-Fi. We're receiving it, we're decoding it, and we're sending it back to the HMD. And the goal, as I think you saw, is that it's almost impossible to perceive any difference between the two. You cannot see the compression artifacts, you cannot perceive any additional lag.
Okay, because it was quite good. It was quite good. So next question for you is, how far along are you? I mean, we're presenting this in a hotel room, but how far are you from actually having something in practical form?
Yeah, so this is a technology demo. It's not yet ready for something that a consumer can buy. And to be honest, our go-to-market strategy on the cloud is to really work with service providers, people that actually have the relationship and the end-mile connection. The wireless solution is coming. We will, in the next couple of months, show a higher resolution HTC Vive and Oculus Rift. And that, we think, could be used by a number of enterprises. In fact, we have quite a few enterprises that are very interested in both wireless VR and in the future cloud VR. I also want to briefly mention that there are a number of approaches to do wireless VR. A lot of people are using 60 gigahertz. We personally don't think that that's the right approach. First of all, the bandwidth is only just sufficient for today, and we know that VR is going to rapidly go up in resolution and frame rate, so there isn't the headroom. Secondly, the challenge with the 60 gigahertz technology is it's a line of sight technology, meaning that as soon as a person interrupts the line of sight, all of the signal is lost, and the video basically breaks up. You can position the antenna on the ceiling, which helps, but then you've got to run a cable and actually install, and people don't want to have to do that. Whereas if you use 2.4 and 5 gigahertz and regular 802.11 AC and H.265 compression, you don't have any of those limitations.
Didn't know about that line of sight. Now I got to go do those interviews all over again. Yeah. But okay, well, good stuff. So, well, thank you so much for joining us.
No, thank you. It's been great.
Okay, this is Neil Schneider for MTBS-TV at CES 2017. We will, of course, be back with more. Thank you for watching.